We are the Gujarat Technological University. Since its inception over a decade ago, GTU has been empowering young and curating minds to realize their true potential. Over 4 lakh inspired students are enrolled with one of the premier academic universities in India. With more than 450 affiliated colleges in its fold operating across 5 zones of the state, GTU, the International Innovative University, your place to move forward.
Hello students, in this video lecture we will discuss about the Murray loop test. The Murray loop test is used for finding the fault in underground cable. This test is useful only for shunt fault like short circuit between the conductor and earth or between the conductor. The test is not applicable for open circuit fault. Now, in Murray loop test, this test is based on the bridge circuit arrangement. We all know about a Western bridge circuit. Here, there are 4 arms P, Q, R, S, which is connected with the supply, and the galvanometer is connected between these 2 arms. Now, when between the 2 points A and B, the voltage is same, it means the bridge is balanced. And the galvanometer will show 0 deflections. If the galvanometer shows some deflection, it means the bridge is unbalanced. If galvanometer shows 0 deflection, it means the bridge is balanced. So, the Murray loop test used this Western bridge circuit arrangement. Now, we will see how this Murray loop test works. First of all, we are drawing 2 cables. Here we are drawing 2 cables. One is faulty cable and the second one is healthy cable. Now, these 2 cables are connected with some common link using low resistance wire. Low resistance wire. Now, assume that here is the fault occur, and then now the fault will connect it to the ground. Take this as a test point. Now, the resistance of healthy cable, assume that it is a small r, and the length of healthy cable is, let's assume that it is L. And now this portion up to the test point to the fault location, take the resistance X, and the length from test point to the fault point, take length L1. And now the resistance from this healthy cable to the fault point of faulty cable, now assume that it is capital R. Okay? This is capital R. Now add another 2 resistance P and Q for completing the bridge circuit. Here we are connecting galvanometer between these 2 points, and now here take this, it is a P and it is a Q, and they are connected to the battery, and from battery to the ground. Okay. See, this is the Murray loop test method model. We take healthy cable, faulty cable, and the two resistance P and Q. Now, these two resistance P and Q are variable resistance. Okay. Now, we will write the bridge balancing equation. For bridge balancing equation, we are writing, here we are going for bridge balancing equation is P by Q is equal to R by X. Okay. Now, adding +1 on both LHS and RHS side, then the equation will begin P plus Q plus 1 is equal to R by X plus 1. Okay. Now, simplifying this equation, it will become P plus Q by Q okay. You can see this equation by adding +1. Now, if we consider this R plus X, okay. So, what is R? It is the resistance of healthy cable plus faulty cable. Okay. It is a resistance of healthy cable plus faulty cable. So, this is the same resistance as a small r 2 times. So, we are taking R plus X is equal to 2R. Now, again rewriting this equation, it will become P plus Q by Q is equal to 2R by X. Okay. Now, finding the value of X, making X as a subject, the equation will begin X is equal to 2R into Q divided by P plus Q. The equation is X is equal to 2R multiplied by Q divided by P plus Q. Consider this equation as a equation 1. Now, here you can see the length. The length of healthy cable is L and the resistance is small r. So, if we take the 4 L length, the resistance is R. Then for unit length, the resistance is R by L. Okay. So, here we have another length L1, which is the length from test point to the fault location, fault point, and the resistance of this length is X. So, for X, the length will become is X divided by R by L. this is a R resistance. Now we know the value of X, sorry, this is a capital X, we take in a question. Now we have the equation of X, which is 2R into Q divided by P plus Q. Now put this value of X in this equation 2. So the equation will become L1 is equal to 2R into Q into L into R into P plus Q. So cancelling this R and R, the equation become 2L into Q divided by P plus Q. So here this is the last equation of L1, which is the distance between the test point to the fault point. So from this equation we can find the distance of the fault and we can locate the fault in underground cable. P and Q, we know that these are the P and Q and their values are known and they are the variable resistance. So from this equation we can find the location of underground fault in underground cable. So this is how Murray loop test work for finding the fault in underground cable. Thank you.